Welcome back to Within the Nucleus, your go-to podcast for all things regenerative medicine. Today we are diving into the fascinating world of nuclear mechanics and its impact on tissue regeneration. Joining me is Basudha, who's a budding scientist and with a lot of expertise in cell biology, nuclear dynamics, and passion for regenerative medicine. Welcome, Basudha.
Thank you for having me, and I'm excited to discuss this topic with you today.
Let's start with basics. Can you explain what nuclear mechanics is and why is it important in the context of tissue regeneration?
Certainly. Nuclear mechanics refers to the physical properties and the behavior of the cell nucleus. So this includes how the cell responds to mechanical forces, it maintains its structure, and also interacts with the surrounding cellular environment. Understanding this nuclear mechanics is extremely crucial because the nucleus plays a central role in cell function and identity. And in tissues that experience mechanical stress, such as muscles and connective tissues, the nucleus must adapt to these forces to maintain a proper function and support tissue regeneration.
That's fascinating. How do defects in nuclear mechanics contribute to diseases like muscular dystrophies?
Defects in nuclear mechanics can lead to a variety of issues. For example, in muscular dystrophy, mutations in the nuclear envelope proteins can compromise the nucleus' ability to withstand mechanical stress. And this would eventually result in damaged nuclei, which would affect the gene expression and cell function. Over time, this would lead to muscle weakness and degeneration. So understanding these defects can provide better insights into how to protect and support tissue regeneration and maintenance in the affected individuals and patients.
So the nucleus isn't just a passive structure, it actively responds to mechanical forces.
Exactly. See, the nucleus is dynamic and responsive. It integrates mechanical signals from the environment and adjusts its function and structure accordingly. And this responsiveness of the nucleus is essential for tissue homeostasis and regeneration. When this process is disrupted, it can lead to a variety of diseases and impaired tissue repair.
Can you give us an example of how studying nuclear mechanics can improve tissue regeneration?
Absolutely. One example is in the field of muscle regeneration, and I am glad to have also worked on this field. So, by understanding how the nucleus responds to mechanical stress in muscle cells, researchers can develop strategies to enhance muscle repair. This might involve using biomaterials, scaffolds, growth factors that mimic the mechanical properties of native tissues, or designing therapies that target the nuclear envelope proteins that would eventually strengthen the nucleus. These approach altogether can improve the regenerative capacity of muscle tissues and potentially treat conditions like muscular dystrophy.
That's incredible. What are some of the current research directions in the field?
Current research is focused on several key areas. One is developing advanced experimental methods to study the physical properties of the nucleus. So this includes techniques like atomic force microscopy or micropipette aspiration, which allows researchers to measure the mechanical properties of nucleus real time. And another area is understanding how nuclear mechanics influence the gene expression and cell behavior in mechanically stressed conditions. Additionally, there is a lot of interest in designing biomaterials and scaffolds that can support nuclear function and also enhance the tissue regeneration process.
It sounds like there's a lot of exciting work happening in this field. What are some of the challenges researchers face?
So one of the major challenge here is the complexity of nuclear mechanics. The nucleus being a highly dynamic structure, its mechanical properties can vary depending on the type of cell and the environmental conditions. Moreover, translating these findings from basic research into clinical applications has been challenging. And so ensuring that these new therapies are safe and effective requires rigorous testing and optimization.
Despite these challenges, the potential benefits of understanding nuclear mechanics are immense. Thank you, Vasudha, for sharing your expertise with us today.
My pleasure. It's an exciting time in the field and I'm glad we could discuss this.
And that's all for today's episode of Within the Nucleus. We are happy to discuss this, and I would soon have Basudha back, where we'll discuss other aspects of regenerative medicine in another series. I'm glad you were with us in these 3 episodes of Within the Nucleus. We will soon come back discussing other organelles. Thank you very much for listening to us. Bye bye.